All right, so this is an example. So what is the present value of an annuity that pays $500 per month for 5 years if the money is worth 6% compounded monthly? All right, so remember our PV equals the payment times the 1 minus 1 plus I to the negative n all over the I. And so now we just kind of plug in what we know. Well, payment is 500, I is 0.06, and this is monthly, so it's divided by 12. Now they go ahead and put it out as a decimal. You could leave it as a fraction in your problem, that's fine. And then n is 12 times 5, which is 60. So plugging it into that formula I just told you about, what we end up with is $25,862.78. So that's going to be the present value of that annuity given the information there. Here's another example for retirement. So an ordinary annuity earning 6.2% compounded annually. So here our thing is going to be this divided by 1. So it's really just going to be 0.0625. Is structured so that a person makes equal annual deposits into the account for 25 years and then withdraws 20 equal annual payments of $30,000, reducing the balance back to zero. Now, how much must be deposited annually to accumulate enough money to provide these future payments, and how much total interest is earned during this 45-year process? All right, so first we have to find future value and present value. So to find the present value necessary to provide for that total payment of $30,000 at 6.25% for 20 years, we plug that in and we find out we need to have $337,221.62 in the account. Now, how do we get to that? Now we have to find the payment. So at the time withdrawal begins, there has to be that much in there. So now we need to find the sinking fund, which is what we looked at in section 3.3, to find the annual payment required to accumulate that much after the 25 payments with the future value of that and given the interest rate. So that payment we found was future value times I over 1 plus I to the n minus 1. Plugging all that in, we end up with a payment of $5,933.29. Now, we're going to make that for 25 years. And so what we have to do is figure out how much is being, paid each year in, and then how much is taken out each year. So basically the total withdrawals minus the total deposits, and that's going to give us our total interest earned. So we took 20 times 30,000, that's how much we're taking out, and then we're subtracting off the 5933.29 times 25, and we end up with $451,667.75 in interest earned. Okay, so a lot of this is really, it sounds good, but again, you really have to get that interest rate, otherwise you don't get that amount. So if you're not getting that interest rate, if you're getting 0.0001 or even just two decimals one or something like that, you're not going to be meeting these requirements, and so it's going to take a lot longer to get that money saved. All right, so let's stop there and we'll come back for some more.